split fractions a little bit, but they didn't have anything like this going on. So this has got a radical in the denominator, and I can't do that to leave it in simplest form. So before we talk about that, I want to ask you a question. What is 2 over 2 equal to? 1, right? How about negative 3 over negative 3? What's that equal to? 1. Anything divided by itself is 1, correct? So how about if we did x over x, what would that be equal to? 1. Anything divided by itself is 1. What if we did the square root of 2 over the square root of 2? What's that equal to? 1. Anything divided by itself is 1. Okay? So, what we do here in order to get rid of the square root of 6 in the denominator is we actually multiply this by the fraction of the square root of 6 over the square root of 6, which is really 1. It's the same value because 2 times 1 is 1, 4 times 1 is 4, 2 times 1 is 2, 4 times 1 is 4, 6 times 1 is 6. You can multiply anything by 1 and still have the same thing, correct? So that's what this is. This is just multiplying it by 1. Now remember, when you multiply fractions, you go straight across, numerator and denominator, straight across. So let's see what this does for us. My numerator is just going to be 7 times the square root of 6. My denominator is going to be the square root of 6 times the square root of 6, which we could just write as the square root of 36 for now. Maybe you don't need to do that step, but we'll write that. And then to finish this, I can actually take the square root of 36, and I have a denominator of 6. Oh, look at that. We got rid of the radical in the denominator. It's pretty funky, isn't it? Pretty radical, that's right. It's pretty radical. So we're done. Now, it's somewhat tempting. I know it's somewhat tempting to say, can you reduce the 6 over the 6? No way, because the 6 is locked in underneath the square root sign here. It doesn't actually have a value of 6 there. It's the square root of 6. So don't be tempted to do that. I know sometimes people want to do that. So that was rational. You just rationalize the denominator to get rid of the radical. Let's do another one. Now I found when third hours started to do their homework, they tucked their notes away and they just like were way off track. So I want you to exactly follow the process that I'm showing you, and it involves a lot of writing. Skipping steps is kind of tricky. So the first thing I'm going to do is split this up like you were doing before. You just took the fraction and gave them each their own square roots. So I need to get rid of that square root of 5a. So what do I multiply by? 5a. Yeah, I multiply by the square root of 5a over the square root of 5a. That's really just the value of 1 right there. That's just multiplying by 1. And then when you multiply straight across. So in my numerator, let's talk about the top. We could write it as the square root of 3a times the square root of 5a, or we could go ahead and multiply 3 and 5. What do we get? 15. So I'm going to, the square root did not go away, so my numerator is just the square root of 15a. Now the denominator. I have the square root of 5a times the square root of 5a. It actually just leaves me with what? 5a. It just gives me 5a. Okay, now I stop and say, can 15 be divided by anything on that perfect square list? Yes, no, maybe? No? So I can't go any further. I'm done. I cannot do any more simplifying. This is it. It's as far as I can go. Okay, this one is a little bit longer, so I'm going to kind of bring it down here. 9, 2x, square root. I'm going to start down here. What's the first step you should do? What did I do up here? What did I do? I'd split it apart. Okay? So I'm going to write it as the square root of 9 over the square root of 2x. Now my goal is to get rid of that radical in the denominator, which means I'm going to multiply this by a fraction of what? Yes, the square root of 2x over the square root of 2x. So now I'm going to write what that's equal to when I multiply this fraction. Now, you have options. Stop and look at it. You could say it's the square root of 18x. Yes, it is. But there's a step you could do that would be easier. What's the square root of 9? Can I just take that right now? Yeah, I'm going to. Square root of 9 is 3 times the square root of 2x. So stop and just make sure you're taking the easiest path. You could still get there if you made it 18, you would just have to simplify it. And then my denominator is the square root of 2x times the square root of 2x, which leaves me with just plain old what? 2x. Now, you always got to stop and say, can that fraction be reduced? Can 3/2 be reduced? No. I can't divide anything from under the radical. Just so I'm done. That's as far as I can go. Not too bad, huh? All right, so that is the first part, rationalizing denominators. The second part you have to do is add or subtract radicals. So in this section, this skill, you need to look for like terms, meaning the same numbers under the radicals. Same radicand, basically, if you want to use that word. Looking for like terms. Like terms means they have the same radicand, the same number. So, let's look at this first one. We have 7 square root of 14 plus the square root of 21 minus 4 square root of 14. Do I have the same number under a couple of those? Yeah. So what I'm going to do is I'm going to take the 7 square root of 14s that I have and take away the 4 square root of 14s. So how many square root of 14s am I left with? 3. I can subtract these two because they're the same. So I'm left with 3 square root of 14s. If you look at it like this, if you just look at it, some people have a hard time visualizing what this means. It's just think of it as an x. You have 7x, take away 4x, you got 3x. Instead of an x, it's a square root of 14. They're like terms. And then you still have the square root of 21. Can either of these be divided by a number on that list? No. So you're done. As far as you can go for that one. All right. This one here, they're not alike, but 28 can be simplified. It can be divided by what number up there? 4. So I'm going to keep the first term the same. Not doing anything with that right now. I'm going to rewrite the square root of 28 as the square root of 4 times the square root of 7. I'm trying to get like terms. That's what I'm trying to do here, so I can combine them. All right, so the first part is 2 times the square root of 7. What happens here? What's the square root of 4? 2. Oh, isn't that nifty? Look what happened. Now I have like terms. I have 2 square root of 7s plus 2 square root of 7s. How many total square root of 7s do I have? And I'm done. Your goal is to try and get like terms. Same thing here. You try this one. Try this one on your own. Same idea. as we just did. It's not too bad. Okay, so that's add or subtract radicals. So you're going to have to do some rationalizing, you're going to have to do some adding or subtracting, and look what's next. Multiplying, okay? It's not too bad. So we're going to distribute. These are just numbers. Nothing scary about them. They're just numbers. So you do the same process. So I'm going to write it the right way. I have the square root of 3 times 2. So 2 times the square root of 3. I just flipped the order. That's the first term. 2 times the square root of 3 plus the square root of 3 times the square root of 12. And then we have to make it pretty. 2 times the square root of 3 stays the same. What can I do to this to help me simplify? Multiply them together, so it'd be actually the square root of what? What's 3 times 12? Oh, look at how nice that turns out. I can't do anything with this first term, but I can take the square root of 36, which is 6. And that's as far as I can go. I can't combine them. They're not alike. So that's about it. Now, this one here is long, so give yourself a lot of room. We have a binomial times a binomial. What method did we use? Other than box, we used what? FOIL. Do you want to use box or do you want to use FOIL? If you want to use FOIL, use FOIL. I'm going to set it up as a box this time. So, it's okay, we can do that. Use FOIL if you prefer that. I'm going to put the square root of 2 up here and the square root of 5 here. Down here I'm going to do square root of 2 and negative 3 square root of 5. I've not done with this with a box. We'll see. It should turn out okay. So the first box, we have square root of 2 times square root of 2, which actually equals what? Just what? It's just 2. Okay, square root of 2 times square root of 2 is the square root of 4, correct? What's the square root of 4? 2. So it's just 2. Then we have square root of 2 times square root of 5, which would be square root of what? 10. Okay, now here we have negative 3 times the square root of 5 times the square root of 2. I still have negative 3. What's the square root of 5 times the square root of 2? Square root of 10. Right? Okay, then I have this one times this one. Ooh. We have negative 3 times the square root of 5 times the square root of 5. What's square root of 5 times square root of 5? Which is what? So we actually have 5 times negative 3, which is negative 15. Yeah, I heard you. All right, now we're going to write that as a sum. So what we have here is 2 plus the square root of 10 plus negative 3 square root of 10 plus negative 15, which is the same thing you would get if you FOILed. And now we combine like terms. I just took what was in this box and wrote it out as a sum. What's 2 plus negative 15? Yeah, I'm going to combine those because I can. That's negative 13 plus. How many square root of 10s do I have here? Right here. 1. There's a 1 there. Plus negative 3 square root of 10. So it's just negative 2 square root of 10. Combining like terms. And that's as far as you can go. They're no more alike. You can't combine anything else. That's it. This one's a little bit easier. We're going to write it out as a FOIL. It's the square root of 3 minus 4 times the square root of 3 minus 4. This one will go a little quicker. Square of a binomial. So if I FOIL it, first terms, square root of 3 times square root of 3 is what? 3. Square root of 3 times square root of 3 is 3. Then I'm going to do the outer two terms. Before that, I'm going to switch it to adding a negative. So square root of 3 times negative 4 is going to give me negative 4 square root of 3 for the outer, plus the inner, and then multiply the last two, which would be 16. So digest that for a second. See if you see, figure out how I got that. Okay. Now we can combine like terms and be almost done. 16 and 3 is 19, plus negative 8 times the square root of 3. And that's all you can do. Almost done. Negative 4 square root of 3's plus negative 4 square root of 3's is negative 8 square root of 3's. Okay. So this says, this is a crash investigator. An investigator can determine the speed in miles per hour of a car by using the formula S equals the square root of 27L. Is this true? I don't know. Where L is the length in feet of the car's skid mark. So if there's an accident on the highway, they can tell how long somebody actually did brake. Like if they're being blamed for an accident, they can actually tell. Perhaps that's the reason they need to find out how long they actually did brake for before they stopped. So simplify the formula. All right, well, here's the formula. When they say simplify, that must mean that 27 can be divided by a number up there. What can it be divided by? 9. Yeah. So it's going to be the square root of 9 times the square root of 3 times the square root of L. I just split them all up, see if I could do anything. What's the square root of 9? 3. And I can't do anything with either of those, so they just go back together under 1. And that's it. That's as far as I can go. And then it says the skid mark is 96 feet long. That's L. What is the speed of the car? So I just have to plug it in to this right here. The speed would be 3 times 3, square root of 3 times 96. Now, since they're talking speed of a car, I don't think they're going to leave their answer in simplified form. I think they're going to find the decimal form because they want to know how fast it was actually going. So I did that, and when you do this math, you get approximately 50.91 miles per hour. So think about that. If you're traveling almost 51 miles per hour, this says that it will take you 96 feet to stop if you brake. Because you have so much momentum going that you're going to skid that far. It's kind of long before you actually stop. All right?